talk about the cross product. So you may have read the definition. Given the vector u and the vector v in 3 space, represented by x, y, z, and a, b, c, the cross product of u cross v is equal to this formula. Now you don't have to memorize that formula. I'm going to show you how you can use simple math to figure this out. Let's look at the example. Find a vector that is orthogonal to both u 3, negative 1, 2 and v 4, 0, 5. First off, we have to note that orthogonal means perpendicular. Okay? Orthogonal and perpendicular are the same thing. So what this is asking is to find a vector that is perpendicular to both of these vectors. That's what the cross product yields. The cross product gives us a resultant vector, so a third vector, that is perpendicular or orthogonal to u and v. This is different from the dot product, as that gave us a scalar value. Cross product gives a vector, dot product gives a scalar. How we do this is we set up a matrix. We have u cross v. We set up a matrix like this. ijk is a unit vector that is a placeholder in this matrix. It ensures that our answer is in fact a vector and not a scalar value. If it's u cross v, then we have to put u first and then v. The order matters. If it was v cross u, we would switch it, and in our answer, the signs would switch. Now, if you haven't solved the matrix before, we're going to do a pretty simple version, where we solve for I, or those x coordinates of our resultant vector. And what we do is we look at the values that are not directly vertical or horizontal to I. We multiply them together and subtract them from each other. So I is going to look like negative 1 times 5 minus 2 times 0. It's always the cross multiplied together, subtracted from the other cross. So negative 1 times 5 minus 2 times 0. We do the same for j. Where we don't look at the values directly vertical to j, and then we do 3 times 5 minus 4 times 2. 3 times 5 minus 4 times 2. We do the same thing for k. 2 and 5 are underneath k, so we ignore them. And then it's 3 times 0 minus negative 1 times 4. Note that our values for I and k, or x and z, are positive, and our j value, or our y coordinate, is negative. This is the same with our equation, I minus j plus k. So you have to make sure you keep track of those negatives when you're solving for your final answer. This is negative 5 minus 0, so our x value is negative 5. This is 15 minus 8, so 7, but negative, so our x value, or our y value, is negative 7. And this is 0 minus negative 4, so our z value here is positive 4. Our resultant vector of u cross v is another vector, negative 5, negative 7, 4. And that's the cross product.